All right, cool. So, hi guys, thanks for coming out to Hackschool session 6. We appreciate you for staying with us so long. um, but yeah, this week we're covering asynchronous programming and web APIs, which is a little bit of a change of gears from what we've been doing the past few weeks. We've been doing mostly React stuff, right? But this is going to be more of a look at a new method of programming, something to like expand your tool belt, so to speak. So let us get into that. Here we go. Okay, as always, if you want to link to the slides, you can scan this QR code, and we also have a link to the README. It's also up here if you don't want to look at the slides. But yeah, check that out if you want to check it out. Oh, oops, sorry. I accidentally clicked on the link. One sec. All right, here we go. So the membership portal code this week, you know the deal with the membership code by now. It's sync up because we're covering asynchronous programming, just a little play on words. Yeah, and also the feedback form, as always, we would appreciate if you give us any feedback. You'll also be entered in a raffle, so please fill that out. It is a good way to tell us how we're doing. Okay, and again, we say this pretty often, but please ask questions. Don't be shy, speak up, or you can, ask questions during the breaks, whatever works for you. And if you need me to slow down or speed up, whatever, I am more than happy to do that. So, okay, don't be shy. And for this workshop, make sure you have a text editor and Node installed because you're going to be doing some programming at the end. So just make sure you have that ready. And try not to code along unless I say to code along, just because you're gonna lose track of where I am if you try to do that. So unless I say, it's up to you. You can do whatever you want, but just try to, just listen to me, please. Yeah. Okay. Cool. So that's all the logistical stuff out of the way. We can go ahead and get started on the actual content. Okay, cool. So you might not have realized it, but up until this point, you've been writing something called synchronous code, right? And in synchronous code, every function and every expression that you write in your program is executed one at a time and in the order that you write them, right? So a more digestible way to think about it is that all the expressions in your code are waiting in line, right? Like this line up here. But they have to wait their turn to be executed. So for example, this 1 + 1 up here, it just gets executed. And then this console.log has to wait for this 1 + 1 to be executed before it can go. And likewise, this function load big data has to wait for this to finish executing, and this get price has to wait for load big data to finish executing before it can be executed. Right? So every task in your program, no matter how long it might take, is executed one by one in synchronous code. And that's fine for a simple program where every task is completed really quickly, right? But what happens when a task is super resource intensive and takes a very long time to complete? Well, if the code is written synchronously, all the tasks that come after that code will be stuck waiting for it to wrap up, right? So this could potentially freeze up your app. It's a bad user experience, and we definitely don't want that, right? So let's avoid it. How can we do that? Give you a little sneak peek there, my bad. Well, enter asynchronous programming. So essentially what asynchronous programming lets you do is it lets you add more lines. So thinking back to the line analogy from earlier, it lets you add more lines to your code so that more than one expression can be executed at a time, right? So let's do some imagining. So imagine you're at the grocery store, right? And you see this. There are two lines. You see this line up here at the top with a ton of stuff, right? Someone just loaded up. They haven't been to the grocery store in 2 weeks, 3 weeks. They need a lot of food, right? And at the bottom, no one is in line, right? So which line are you more likely to take? Hopefully, you're thinking the empty one, right? So because on the top, this shopper has a ton of stuff loaded. You have no idea how long it might take for them to finish scanning each thing. They might start up a conversation with the cashier, and it'll just be a while. So if you get in line behind them, you could be waiting for 15, 20 minutes, 30 minutes, who knows. So by taking the empty line, you save yourself a lot of time. So let me just, oh yeah, that's me. So I took the empty line. I decided to take the empty line because I wanted to save some time, right? Cool. So now imagine instead of shoppers waiting in a line, we have tasks in our program waiting to be executed, right? So we want each task to get going as quickly as possible, and we don't want to keep them waiting. So asynchronous programming is going to solve this problem, right? So if there's ever some task that takes a really long time to complete, but you're not sure how long it might take, like for example, loading an image, you don't want to freeze up your application while you're waiting for it to load, right? So like I mentioned before, since we have more than one line, asynchronous programming is going to let us execute more than one expression at a time. So we no longer have to wait for this intensive task to complete before moving on to some other thing, right? So yeah, we just add more lines and yeah, that solves our problem. So looking back at our little grocery store example here, say like this cart is like some task, right? Loading some data, loading an image, loading a video, whatever. We don't know how long it's going to take to complete, right? So instead, we take this other line, we wrap up whatever we want to do very quickly, right? So that's the plus of asynchronous programming. All right. Are there any questions about that, just asynchronous programming in general? All right, cool. So now that you know what asynchronous programming is, let's get into how you might actually want to use it. So let's say that we have some function called simulate intensive task, right? And this function takes some amount of time to complete. And when that task is completed, we're going to see a message logged in the console. And don't worry about the details of this function. It doesn't really matter, just some arbitrary task that gets done. So the return value of this function is going to be how long the task took to complete in seconds, right? So let's go over to our code example here. Just remember, it doesn't really matter what the function does. It's just going to log a message in the console when it gets done. Okay, so let's go over here and take a look. So I whipped up this React app really quickly. I don't really know why I use React. It's kind of overkill, but I use React. So here we go. It just consists of two buttons. One button says click me, and when it gets clicked, it executes this function. And then a second button that says other click, and it executes this function when it gets clicked. Right. So let's take a look at what this is going to look like in the browser up here. So here you go. Let me just show that this works. Let me pull this up. So you can see that this executes, this prints yo. Oh, right, yeah. One sec. How's that? Cool, okay. So you're gonna see that this prints yo when we click it, just as we would expect, because this button executes this function when we click it, right? So let's add our function, simulate intensive task. I want it so that when I click me, the task starts, right? So I'm gonna write, I have a predefined function. I'm gonna write simulate intensive task, right? Oh, I did not, I commented it out. There we go. Here. Okay, cool. So now when I click this button, we're going to see something interesting happen. So let's do it. All right, cool. So what we saw happen was first, as soon as we clicked it, there was an initial press, right? That was logged. And then after the function was completed, as we expected from our definition of what the function does, it prints this task took 1.793 seconds to complete, right? And let's just try that again. So we see initial press, and then again, 1.949 seconds. That's how long the task took to complete. Okay, but let's see what happens if we click this button after we click this button. So I'm gonna click this, and then right away, oops, I messed the button. I'm gonna click this, and then right away, click this. Okay, so I don't know if you caught that. It's kind of hard to see, but what happened was this did not get printed until this finished. So let me just try that again to give you a better idea. So I'm going to click this, and then right away click this. And then again, this only gets printed after the task finishes. And that's because this is a synchronous function, right? Let me go back here, right? This is a synchronous function, which means that everything that comes after it has to wait its turn to be executed, right? So you can tell that this is true because even though I clicked this right after this function was executed, it didn't get printed until the task was completed, right? So that's what we would expect from synchronous function. So how can we make this better? So, lost my mouse. Here we go. Let us move on to our next function. So this is not great UX, right? It pauses our whole UI. It's just not the best. So how can we make it better? Let's try using an asynchronous function, right? So we have another function here, simulate intensive asynchronous task. Again, don't really worry about the details. It doesn't really matter. It just does some arbitrary task, right? And when the task is completed, a message is going to be logged in the console. And again, it's going to return how long the task took to complete. So let us see this. I'm just going to add async here. All right. So let's take a look at how this works now. I'm just going to clear the console out here. Okay, so I'm going to just click this initially just to show you that it works pretty similarly. So you see initial press. Not sure why this is cut off like that, but it doesn't really matter. So you can see that there's the initial press, and then again, it logs how long it took to complete in seconds, right? So I'm going to do it again, similarly to how I did it last time, where I click the second button before the task is completed. So I'm going to click this, and right away, you can see that this was printed, right? So this function did not have to wait its turn to be executed, right? And that's because this is an asynchronous function. So let me just do that a couple more times just to demonstrate, so you get a better idea. So boom, you can see that it gets printed right away. And then this, when it gets done, also prints 2.019 seconds, right? So that's great. Okay, let's just make sure that our function is asynchronous. So I'm going to go back to the code, and I'm going to print. Let's just say that I want to print the amount of milliseconds that the task took to complete. But I'm really bad at math, so I need to use a computer to figure it out. So remember that this function returns how long the task took to complete in seconds. So I'm just gonna go out here. Oops, 1 sec. Sorry, I have to look back at when I'm typing. It's very jank, so sorry about that. I'm just gonna say ms. Oh, actually, this is gonna be seconds because this returns the time in seconds, right? Okay, so that's that. And then I'm gonna say console.log, and then I'm gonna say milliseconds. And then since there are 1,000 milliseconds in a second, I just do 1,000 times sec, and that should give me the number of seconds. Right. So let's see if this works as expected. Okay, let me just clear that and scroll down, and here we go. Okay, that's a little bit weird. So we see milliseconds, and then not a number, right? So this NaN thing, you might not have seen before, but if not, all you need to know is that it just represents something in JavaScript that is not a number, right? But that's kind of weird, right? Because we expect seconds to be a number, we expect milliseconds to be a number. So why is this printing not a number? What's going on? I don't know. But let's try to investigate a little bit further. So I'm just gonna remove all this stuff because it's just dressing basically. And I'm gonna see what this prints out if I just print this. Okay, so let's see. All right. All right, so we see that it prints out something called a promise, right? So what is that? I have no idea, but it's definitely not a number, right? So that makes sense. You want me to zoom? Okay. I will zoom. There we go. So you can see the promise here, right? Yeah, so what exactly is a promise? Let's take a look back at the slides. Okay, so you can see that we had a bit better UX, but we do have a problem with that whole promise thing. So let's look into that a little bit more. Okay, so what is a promise? Basically, it's just a wrapper for some unknown value that's unknown at the time when the promise is created, right? So in the previous example, when we log the number of seconds, we don't yet know how long the task took to complete, right? So the seconds variable has to be a promise at the time when the button is clicked, right? But how can we then retrieve that value from the promise, right? Well, there are a couple ways. Oh, by the way, this is called resolving the promise. And it's also important to know that promises can be rejected, but that is something I'm not going to talk about today because I don't want to go too in depth. But yeah, so like I mentioned before, this promise is just a wrapper for some unknown value. So we then want to retrieve that unknown value when the value becomes known, right? So there are a couple ways to do this. One of them is called .then, right? So .then, I'm just going to show you the syntax for it before I go in too deep on it. But so this is our function from before. Remember that this returns a promise, as we saw. You can see that I printed this value, which is the return value of this, and it came out as a promise, right? So we know that this is a promise. I'm just going to replace it with promise, just to make it a little bit shorter. And then I'm going to add this .then function, right? I'm just going to call .then on the promise. And then I'm going to pass in this function here, this error function. And then I'm going to console.log the value, right? So basically this was a lot, but what I'm doing is this value here is just the resolved value of the promise. And we can treat it, we just choose to call it value, right? So instead of printing promise, or instead of printing not a number, it's going to print the actual value that we expect, right? So all this is doing is it basically just waits for the promise to complete, to be resolved, and then we can access that value through this, this name here. Okay, so let's take a look back at our code and try to do this. So I'm going to get rid of this. Actually, I'm just going to cut that so I can paste it later. And then boom. And then I'm going to call .then on this. So, and remember that this returns the number of seconds, right? So I'm going to call this value, this value out here, seconds. And then boom. I should change that. Okay, so let's see if this works as expected. So I'm going to go back over here. Now I'm going to clear this. Okay, boom. All right, awesome. So you can see that it didn't print not a number, it didn't print promise, it just printed 1.079 seconds, which is the same value as this up here, right? So that's great. So that is one way to resolve promises, but it can get out of hand very quickly because we can have nested promises, right? And we can have promises within promises, within promises, within promises, within promises, within promises, within promises, right? And it just gets very out of hand very quickly. And at least something we like to call the pyramid of doom, which is just a very ugly looking code, right? So we want to try to avoid this. Luckily, recently, there's been a new addition to JavaScript called async await, right? So let us take a look at async await. I do want to emphasize that it's basically the same thing as .then. It's just a different syntax for using or for resolving promises, right? So here we go. So again, still using promises, still resolving them, just a different syntax. But let's take a look at that syntax. So you can see my promise out here. And then we use something called, well, first we want to assign a value. So we can basically write our code as if it looks as if it was synchronously. So we can say this value here is equal to this promise. Then we're going to have to add this await keyword out here in front of it, right? And then we can basically just use this as if it was synchronous. We don't have to do any further interaction. But we do have to do one thing, which is we need to wrap it in a promise or wrap it in a function that is marked as async. So you can see ignoring this part up here and this part and this part, this looks very close to synchronous code, right? Which is great because we like synchronous code. It's easy to read, and it's just a lot nicer on the eyes, right? So the only difference is we do have to add this await keyword and this async keyword up here to mark the function that we're wrapping with, and then the await keyword to await the promise, right? And it is important to note that this await keyword can only be used in functions marked async. So you're not going to be able to use async await if you don't have this external function here that is marked as async. So that is one drawback of async await, but you'll see that it overall usually ends up looking nicer than .then, in my opinion. Okay, so let's just transform this into async await. So let us get rid of all this garbage. Let me move up here. Okay, so I'm just gonna say, so this is gonna be the number of seconds, right? So I'm just gonna say const seconds equals seconds, or this, the return value of this function. And then I'm gonna wait it, right? Because it is a promise that needs to be waited for, because we don't know how long it's gonna take to resolve, right? And then I can just treat it as if it's synchronous code. I can just log the number of seconds and not have to worry about the weird promise thing being printed, right? But I don't want to forget to mark this function as async. What's nice about this is that we already have a function here, a wrapper function. So we don't need to like have an inner function to wrap this. Instead, we can just mark this as async, and boom. And then we should be good to go. So let's take a look at our code, or at our app up here. And hopefully I did not make a mistake and it works as expected. All right, awesome. So we see the initial press, and then after 1 second, both this message and this seconds value were logged, right? So great, that works perfectly. That's what we like to see. Cool. And I do want to again emphasize that this is .then and async await accomplish the same thing, right? They both resolve promises. They both let you wait for a promise. They both let you access the value that is wrapped by a promise, right? So you can see that this .then just looks a little like this. It has a drawback of often resulting in the pyramid of doom that we saw before. And then this up here, you can basically write synchronous code, but then you're going to have to wrap it in a function. You're going to also have to use these keywords async and await, right? But again, this has to be in an asynchronous function, otherwise it's not going to work, right? Okay, cool. That is that, I believe. So it all comes down to personal preference, whatever you want to use, .then or async await. I personally prefer async await, so I'm going to be using it for the rest of this workshop. Okay. Any questions on any of that? Or if you prefer, we can wait for the break and you can ask to someone walking around. All right, cool. So let's take a break then. Oh, yeah, let's take a break. Let's do like 10 minutes. So let's come back at like 7:40. Here we go. Oops, 7:40. Okay. Cool. Oh, I did not pause the recording. I will do that. All right, let's keep going. So up until this point, we've been just doing we've been simulating tasks, not really actually doing practical stuff. But let's take a look at how we might use this in the real world, right? So, but before that, let's do a quick review of objects. So we covered this a couple weeks ago back in the JavaScript workshop, I think. But let's do some quick review. So let's just say that we want an object that represents a joke, right? And every joke has a category, right? So in this case, it's a pun. Every joke has a setup. In this case, thank you, student loans, for getting me through college, and a delivery. I don't think I'll ever be able to repay you. So regardless of if you think it's funny, it's a joke, and it consists of these three things, right? So to get at these values in this joke, we could either use this dot notation, so to access the category, joke, which is the object name, you can see, joke.category, which is this key. That will be equal to pun. Then we can use joke.setup to access setup, or joke.delivery to access delivery. And again, that will just give us these respective values here. Or we can use this bracket notation. We just, similar to how you would index an array, but instead of having some number here, you have a string, which is the key name, right? So this is going to be category, setup, and delivery. All right, cool. So that was our very quick review. And now let's move on to a new topic, which is JSON, so JavaScript object notation. So very often it's going to be useful for us to store JavaScript objects as string representations, right? So this string representation is going to be called JSON. And what's really useful about JSON is that it looks very similar to an object, right? So we can use it. It's really convenient to use it to pass data across networks, right? And that's going to come in handy. You'll see when we talk about APIs. Okay, so here is our joke object from before. You can see that it looks very similar. This is just a JSON representation of it. So this is all a string. Oh, there should be quotes here, I guess, but whatever. This is JSON, okay? Yeah. So any questions on that very brief intro to JSON? No? Okay, cool, perfect. So now that we know what asynchronous programming is, now that we know how to resolve promises with async await and .then, and now that we know what JSON is, let's put it all together and take a look at how we might apply it in the real world. Okay, so the real world. We often want to use something called a network request, right? And a network request is just a way to get data that isn't stored locally over the internet. So like from a server or something. So that's a computer that's in a far off building somewhere, right? So for example, if we want to download some data, for example, an image or a video, some text, whatever. And we often use something called a web API to interface with these servers, right? So I'll go over this more in depth later, but this is just a brief intro. Web APIs are going to be really powerful because we can use them to tell a server that we want some data, right? So we can use in JavaScript a built-in function called the fetch function, and that's going to trigger a network request using an API, right? So that was a lot, all thrown at you very quickly. So let's break each of these sections down and talk about them more at length, okay? So first up, let's talk about network requests, right? So I mentioned what it was before, but let's just do it again. So you've probably heard this term being thrown around a lot, but what exactly is it? Basically, it's just a request to download some data from the internet, from some far off server somewhere. All right, so you can see these computers, these servers, they probably store a lot of data, and you can request to access them using a network request. Okay, so let's quickly just take a look at an example of this. So let's pull up our favorite website. I'm just going to pull up YouTube, sure. Hopefully nothing inappropriate pops up. Yeah, perfect. Okay, so you can see all these videos. These are basically, if I click on one of them, I will make a network request.
Hey, what's
It's
up?
going to load the video. And you can see that if I pull this up here, the console has a very convenient way to see, where is it? See what network requests are being done. Okay, it looks like I can't really see it because shit is zoomed in, but basically the video was loaded at some point through a network request, right? So let's go back here. Okay, cool. So that's just a quick example of that. Okay. Up next, oh, yeah, YouTube. Let's talk about APIs, right? Before we talk about what a web API is in particular, that's like the topic of today's workshop, right? Let's just discuss APIs in general. So if you don't know, API stands for Application Programming Interface. You've probably heard this term thrown around a lot, but you may not have truly understand what it means. Basically, an API is just a predefined way. Oh, my cursor, there we go. Basically, an API is just a predefined way for developers to interact with code that someone else wrote, right? And they're very useful because they allow us to use code without having to actually understand how it works or like the details of the implementation, right? So we can use code or data that other people have written and interface with it with these APIs, right? So think about a car, right? No matter what kind of car you're driving, the controls function the same way, right? So the steering wheel always changes direction. The shift stick always changes gears, right? The dashboard shows a bunch of essential information. And the ignition key, you use it to turn on the engine, right? So you don't really need to know how these all work. You just know that you know what they do, right? And that's basically how an API functions, right? You don't really need to know the details of the code. You just need to know how to interact with it. And that's what the API defines. Okay, that's great. But what is a web API? Along those same lines, it's just a way to interact with someone's code without having to know how it works. So usually we have the way we access a web API is we use a URL, right? And we access we access that through a network request, right? So in order to talk with these APIs, oh yeah, and by the way, there are a lot of APIs out there, web APIs, and we'll take a look at some of them later. But for now, let's talk about web APIs a little bit more. So this is a lot of text, but basically, the way we talk with web APIs is we use something called an HTTP request, right? And it's essentially just a network request that adheres to certain standards set by some people a long time ago, right? So you can see that an HTTP request consists of a few essential things. There's probably more, but this is just all we need to care about for now. So it has a URL that tells us who our request is for, some kind of method of that basically tells what kind of action you want to perform, right? So you can see one example of that is a GET request and a POST request. I'll be covering this all a little bit more in depth. This is just a brief overview. And then we also have a header that has some important meta information, right? So for example, we have the content type of the request, right? So usually, in our case, we want our content to be JSON, right? So we can mention that in the header. Okay, so let us move on. So the URL, again, just tells who and what your request is for, right? So here's a brief example, or a quick example. This URL basically says, I'm asking this joke API, this this website, to give me a joke, and it's going to be in either the miscellaneous, pun, spooky, or Christmas categories. So you can see that up here. and it has these blacklist flags, which means I don't want to see these jokes, right? I don't want to see not safe for work jokes. I don't want to see religious jokes, political, etc., because that's too edgy for this workshop. So yeah, that is the URL. So let's take a look at what happens if we go to this URL. So you can see this JSON is pulled up, right? This is the same URL from before. You can see that we have our category, which is a pun, a lot of other stuff too, but let's just focus on what we had from before. So we have a setup. Why do cows wear bells? A delivery, because their horns don't work, right? Yeah, great joke. Okay, cool. So that's the URL. Another name for that is our endpoint, but we don't need to talk about that too much. Okay, and also we have, we can use either a GET request or a POST request. There are also other ways of interacting with these APIs, but in our case, we're just gonna be using GET request, which basically means we're gonna be getting some data from the server, right? That's all you need to know. It gets a lot more complicated. Let's leave that and not talk about it too much. Yeah. Okay, cool. We also have a header, which again is just a way to specify some meta information about our request, right? So, for example, like I mentioned before, we can have a content type and we can define it to be JSON, which basically just says that we expect some JSON in our request body, right? Okay, so that is a quick breakdown of that. Oh, and here are a couple APIs. If you pull up the links or the slides, you can check them out. It's going to be helpful for later when you write your own code. Yeah, so here we go. That was a lot, I know. I just wanted to briefly mention that in case you're interested. But let's try to keep it simple today. Let's just try to get some data from a server, right? So we're going to use a GET request for that. Okay, cool. So you might remember I mentioned the fetch request or the fetch function from before. So fetch is just a built-in function in JavaScript that takes in a URL, which is an endpoint for some API, and it returns a promise, right? So it returns a promise because we don't know how long it's going to take to get that data back from the server, right? So that makes sense with what we talked about before. Okay, so we don't have to worry about, again, don't have to worry about most of the request garbage. It's pretty much abstracted away with this fetch function. All we have to do is just pass in our URL, and then it'll handle everything for us. It's great. So you can see that because this returns a promise, I'm awaiting the result of this fetch function, right? So you can see this is our URL for our API, and then we wait for it. Okay. So you can see that has the same syntax as our simulate intensive async task function, and that's because they're both asynchronous functions, right? Okay, but this is not yet the value that we want when it gets resolved. We still have one more step after this if we want to convert our JSON into something usable. So that comes in with the JSON function. So calling .json on the result from before is just going to take that JSON and convert it into a usable JavaScript object, right? So you can see this is the same line I had from before. And then I just call .json on this result, and that gives us a usable object, okay? So that's how we use the fetch function. So let us move on to, oh yeah, and it's important to note that JSON is also an asynchronous function, so you're gonna have to wait on the result from that too. So just keep that in mind. Okay, any questions about any of that? I realize that was a lot. Yeah, what's up? I believe it returns like a network request object. I'm not sure about the exact specifics, but basically all you need to know is that when you call .json on it, it'll take the information that it stores and just spit out a usable object. Okay, so it's kind of like a message. Right, yeah. Mm-hmm. Exactly. Yeah. Okay. Any other question? Oh yeah.
What will be contained in once you call .json if the request failed?
I actually don't know. Does anyone?
Usually, we will have n bunch of requests are making, but for example, one if the request fails, they will return a promise that will resolve into a JSON, and inside that JSON, if you call .json on it, it'll be a JSON, but instead of the data you expect, it's probably something like error fail.
Yeah. There you go. Okay. Anything else? All right. Cool. So let us move on to our demo for the day. So I'm going to move back over here, and I'm just going to comment this out because we don't need it anymore. And I'm going to uncomment this because we're going to need it. Oh, dang it. I can't just use a shortcut. Here we go. All right, cool. And that's going to be annoying. All right. So for my demo, I just want to make a small app that gives me a random joke, uses the same API from before that I showed. It gives me a random joke when I click a button, right? So you can see, again, I set up the starter code. If you want to download it, I have it on the README. You can check it out for yourself. But let us get started. So basically, I just want to make it so that when I click this get joke, or when I click this button, I'm actually going to change this text here to get joke, right? Get joke. When I click this button, I want it to give me a joke, right? And I'm actually going to get rid of this button. I'm also going to get rid of this because I don't need it. Okay. Cool. So I'm going to use this function since this function is called when I click this button, right? So up here, I need to copy the URL from before. Oh, Zoom, go away. No. Okay. I'm just going to drop this up here, and I'm going to call it, const URL. Okay, there we go. So we're going to need that later when we use our fetch function, right? So I am just going to replace this simulate intensive async task because, again, it works very similarly to the fetch function. I'm just going to replace it with fetch, fetch URL. There we go. And this is going to be our, let's call it result, whatever. And then remember that we want to convert that into a usable object. So we're going to do that with the JSON function. So I'm going to say object equals result.json. And don't forget that this is also an asynchronous function. So we're going to have to await this. Okay. So now we can access any field within this object, and we can potentially display it down here. So let's look back at what this object looks like. So we can see that it has category, error, type. I'm only interested in this stuff here. Okay, so I want the setup and the delivery. So let's keep those keys in mind. Let's go back here. Okay, and let me just make a local variable here. I'm going to say, wait one sec. Sorry, my mouse is in limbo. Oh. Okay, so I'm eventually going to call this variable joke. So I'm just going to do that. And remember, when you're using JavaScript expressions in React code or in JSX code, you need to wrap it in these curly braces here. So that's what that is. I'm probably going to need to use some kind of state. So remember from the last workshop, we had the useState function. So I'm going to use that. I'm going to call our variable joke, because that's what we typed in before. And I'm going to call the function to set that, set joke. And I'm going to call useState with a default value of generate a new joke. Okay. And let's just add a smiley face. Why not? Oh, I did not mean to have that capitalized. Here we go. Okay. So I'm just going to call set joke, right? And let's just say, let's set it equal to obj dot, let's do setup, right? Yeah, setup. Obj dot setup plus a space, because we want a space between, and then obj dot delivery, right? Oh my God, it's so hard to type over my shoulder like this.
Interesting question.
Oh, hello, Siri. Okay. Okay, cool. So I think after that struggle that this is complete. So let's take a look and see if this works. Okay, so we can see that our stuff was updated. If I click get joke. All right, awesome. This is updated. How to construct workers party. They raised the roof. Nice. Okay, cool. All right, so that's working pretty nicely. Let us go back over here. And now I'm just going to pass it off to you. So find any API that you like. It can be basically anything. If you want, you can try to find some ideas from these 3 links here. And then I want you to basically just do exactly what I did and display some information from these APIs somewhere. Okay, so I'm going to give you like, let's say 15 minutes to do that. So it's 8:02 right now, so let's come back at 8:17. And I'm going to turn on the lo-fi because why not?
Hey, what's up, guys? Flo here.
Sorry.
Welcome to a new video.
Sorry.
In today's practice,
Hello?
I will guide you.
Oh God. Oh, okay. I did not. Damn it. All right, guys, let's come back so we can wrap up. Okay, so really important that you fill out our feedback form. Here's a link. You can type that in to your browser and it'll pull it up. You can be entered into a raffle, get some prizes, fun stuff. Also, our next session is going to be on lifecycle. It's another React focused workshop. So come out to that. That's going to be next Wednesday at 7 p.m. in here, as always. But yeah, thank you for coming. Appreciate you for staying. And that's pretty much it. So, bye.